Welcome to Essential Git 2nd edition. My name is Jorge Escobar and I have been managing development teams that use Git on a daily basis for many years, and I know firsthand how important it is to be fluent in this fundamental tool. I also happen to have started my online instructor career teaching this course, and after thousands of students enrolled, I have decided to make this 2nd edition that improves and expands the material on this wonderful piece of software. Git has a lot of quirks and it does have a wide range of features, but to be honest, most professional developers only use a subset of the tool in their day-to-day job. So the goal of this course is that you understand from the very beginning and without any previous experience, the essential parts of Git that you will use managing software development in any professional tech company. We will begin our journey by introducing the concept of version control and why it's important. We will then install Git, go over the file status lifecycle, get comfortable through hands-on exercises with our first project, and finally learn all about branching and remote repositories. At the end of the course, we will look at some of the different workflows used today, and finally we will all work together in a real worldwide open source project called the Global Restaurant Guide. So let's start learning the essential Git. Git is a version control system, or VCS, that allows developers to improve the way they work on their code, as well as collaborate easier with other developers in software development projects. Since its inception in 2005, Git has become an essential tool for anyone wanting to work in the computer software industry. There are multiple ways to install Git on each operating system. If you have Linux, Git usually comes pre-installed or just used apt-get install Git on Ubuntu or yum install Git on Red Hat. Let's check what are the best options based on your operating system, Windows or Mac. If you have Windows 10, the best alternative to install Git is to use Chocolatey, a Windows package manager similar to apt-get and yum on Linux. To install Chocolatey, head over to their website and read the instructions. They might have changed recently, but this is how I do it today. To begin the process, open the Windows PowerShell and locate it here on the Windows menu. Now, once you open that, you want to run this as administrator, so you want to right-click on the icon and select Run as Administrator. This will display a prompt. You press yes there and just close the other terminal and make sure that you have Administrator here on the top of the window. Now, usually PowerShell runs with a restricted execution policy, which will be a problem if we want to run the Chocolatey install script. So change this by doing the following command. Set execution policy and type unrestricted. Now you will get a prompt that says if you want to do this, just press yes. And now we should be good to go. Now to install Chocolatey, just click on their install option and copy and paste this command here. Press enter. Perfect. So we already have Chocolatey installed and we need to restart the PowerShell. So we can close that. So go ahead and open the PowerShell again. And you're going to have to do the same thing, open as administrator. And in that new window, check that you have administrator in there. Let's close the other window. And then just type Choco in the prompt. And if you see Chocolatey version something there, then that means that Chocolatey is properly set up. Finally, we can install Git by doing the following command. Choco install git -params and this string. And we just press enter. You want to say yes to run the script. And Perfect. Git was installed successfully. From this point on, whenever I mention open the terminal, I'm referring to the Windows Git Bash program. Although PowerShell is a better terminal program than the regular Windows command line, it is still not as compatible with Unix terminal commands, so we're going to be using that from this point on. To get to the Git Bash, just look at the Windows menu and get to Git Bash here, and that will open the Git Bash prompt. The best way to install Git in macOS is by using Homebrew, which is a package manager similar to Red Hat's Yum or Ubuntu's apt-get. To install Homebrew on your computer, head over to their website at brew.sh. Then open a terminal window. You can find it on the Applications Utilities folder or by doing a search by pressing Command Space and then typing terminal. Then copy and paste the command from the Homebrew install code. After installing, do brew doctor to see if everything is fine, and then do brew update to get the latest updates to the program. Finally, type brew install git, and you should be set to start using Git. If for some reason you don't want to use Homebrew and you are in macOS 10.9 Mavericks and above, you can install Git by using the Xcode development tools. Just open the terminal and type git. You'll get this prompt that says, the git command requires the command line developer tools. Would you like to install the tools now? Press the install button and you wait for the installation to finish. However, this is not the best way to install Git, since this method usually installs an older version. I really recommend you use Homebrew as described in the previous section. To verify that you have Git installed, write Git in the Git Bash Windows or in Mac OS X terminal. You should see a list of available commands. To see what version of Git you have, just type git --version. In this section, we will be introduced to Git's file status lifecycle. We will also learn why the terminal is the best way to use Git and some of the most useful command line tools for file management. If there's one fundamental concept that you need to understand, is how Git manages its files and the stages they go through as you work on them. This movement between stages is called the file status lifecycle, and here's how it works. As you can see here, there are 4 phases a file can go through when they are contained in a directory managed by Git. Depending on the work you're doing on them, the files can go through each of these phases many times. When a file is in one of these stages, we say it's in a specific status. Let's review each status. When you first create a file in a Git folder, the file is assigned an untracked status. This means that Git is not actively watching this file, and it will be ignored if any changes occur to it. There are some files that we want to leave untracked in a project, for example, temporary files or setting files. We can tell Git to ignore specific files or file patterns using a special file called git ignore, which we will look at later in the course. When a file is added to the repository, it will enter a tracked status. From this point on and until you change its status to untracked, Git will be watching this file actively and any changes you make to it will be noted. A tracked file that changes is marked by Git to be on a modified status. This means that the file has pending charges that need to be completed at some point. In a way, this is considered an unstable or dirty state because at some point the file changes need to be completed and moved to the next phase. A file is on a stage status when the work has been completed and it is ready to be included on the next snapshot that will be taken of that project. These snapshots are called commits. Now don't worry if you don't understand all of these stages immediately. Let's try to picture the workflow with an actual file that we're working on. First, we will create a file in a directory that has been initialized as a Git project. As you can see, the file was just created and Git is not watching it. It's on a untracked status. For Git to start watching this file, we issue a command that will move it to a tracked status. The command is called git add. Once that file is being tracked, any changes to it will be detected by Git. Let's say that now we start working on that file and we do some changes to it. Once we save the file, Git will mark it with a modified status. We can now change the files that will be included in the next commit. Once we finish working on all the files we need and we're ready to save a snapshot, we issue the git add command once again. This puts the file or files into the stage status. At this point, we're confident the work is ready to go out. Either we will push it to a production environment or we want other developers to check our work. And we finally issue the git commit command, which will take all the files back to the track status, ready to begin the whole process again. Finally, if for some reason you elect to untrack the file, it would fall back in the untracked status. This would also be the case if you delete the file. In this section, we will start playing with Git. We'll create a repository, check the history of the project, and very important, how to undo operations. But first, let's learn some basic commands to navigate the file system in the terminal. Go ahead and open your terminal, Git Bash on Windows or Terminal on Mac, and you should get a prompt ready for your commands. One of the most important things you will need is to know where you're at any given moment. When you start the terminal for the first time, you are placed in your user's home directory. This directory is where you normally put your own files. Now type pwd. pwd stands for Present Working Directory, which as you can see is your user's home page. The home directory is also referred as the tilde directory. If we wanted to see the contents of this directory, you can use the ls command. As you can see here, we get a list of the files and directories on your home directory. However, the file system might have hidden files in there. These hidden files can be temporary files that are being worked on, setting files, or even whole directories. As a matter of fact, we will see later in this section that the Git directory is a hidden directory. To see these hidden directories and files, we use the command ls-a. The -a after the command is called a flag. The a flag for the ls command lists all the files, hidden or not hidden. As you can infer, hidden files or folders start with a dot. There is another flag called -l that lists all the details of the file, including the permissions, user, and group owner and size. There are commands to handle these file properties, but we don't need to get into these for the purposes of this course. Finally, we can combine the A and L flags in one and get both all the hidden and unhidden files along with their details. If you want to clear the screen, you can use the clear command or hit Command+K on Mac or Control-L on Windows. So let's start our first Git project by creating a new folder. To create a folder, just type the following command: make dir test git and press enter. You should get the prompt back as if nothing happened, but now if you type ls, you should be able to see the directory there. Now we need to change to that directory so that we can start working on our first Git repository. The way we do that is by using the cd command, which allows us to change to a directory. So we do the following: cd test git. Notice how the prompt, which is the text before the command, now reflects that we are in the test-git directory. If you do an ls now, you will see that we have an empty directory. A useful command we will be using a lot is the clear command that clears the screen, so that you can get a blank slate to continue working. In macOS, you can also use Command plus K, and in the Windows Git Bash, you can use Control L. Let's clear the screen and start working on our first Git project. Make sure you are on the test-git directory by typing pwd and confirming you are in that folder. We are ready to initialize our first repository, so all you need to do is type the following command: git init. Git will confirm that you have created a new empty repository in the hidden folder Git within the test-git directory. Within this hidden folder, Git will be tracking all the changes you make to your Git repository. You can take a look at its contents by doing ls.git. You will see a bunch of files and directories that Git uses internally, but you won't be interacting with them too much, with the exception of the config file. The config file keeps a number of settings regarding the repository. Take a look at it by using the cat command. With this command, you can see the contents of any file. So you can do cat.git config. Let's go ahead and use a new command called git status. Git status allows you to see the current status of a repository. Git tells us that we're on the master branch. The master branch is the default branch that a repository starts in. We'll learn more about branches later in the course. We also see initial commit, which basically tells us we're working towards our first snapshot of this repository. Finally, Git tells us that we have nothing to commit to this snapshot and that we need to create or copy files and then use git add to start tracking them. But before we actually start doing any file operations, we need to tell Git who we are, and we do that using the git config command. So go ahead and type the following two commands, pressing enter at the end of each one. Of course, use your own name and your own email. These settings will be saved on the config file inside of the Git directory. You can check this out by typing cat.git/config. One word of caution here: you need to do this every time you start a new repository. If you want to avoid this and just want to have it preset for all repositories, you can pass --global after the config command. Personally, I like to do it every time. I'd rather have control on the Git user as I start a new project. So we're finally ready to create a new file. Since I'm using Atom, I just write the following command to create a new file called test.txt. That will open the Atom editor with the file test.txt open. You might need to close the welcome tabs that open by default. If you get an error related to the Atom command not found, open Atom manually, and on the Atom menu, look for an option that says Install Shell Commands. If this still doesn't work, you might need to open the folder manually using the File Open command. Type any text in the editor window. I will just write test number 1. Notice how there's a little blue dot next to the file name that tells us that the file hasn't been saved. Save the file by going to the File menu and clicking Save, or use the keyboard shortcut Command S on Mac or Control S on Windows. The little dot should disappear. Always refer to this when working with files. Many times an error we're getting is plainly related to us not saving the file. Also, two things happen here. One is that the file name turned green. This means that we have changes to this file that haven't been yet committed. The other is, on the bottom right of the editor, you'll notice a +2 indicator, which means you have 2 lines that have changed on the file that are not yet committed. If you hover over the indicator, you'll see a more detailed message. So let's go back to the terminal and see if Git detected this file change. Type git status and you should see the following output. Git now tells us that we have untracked files and that we can add them to our next commit by using the git add command. These files will be ignored by Git no matter how many changes we make to them. So let's see where we're at in the Git workflow. As you might remember from our explanation of the Git file status lifecycle, this is the very first stage, where the files are on the untracked state as they've been just created. We're ready to start tracking this file, so let's add it to the repository. We can do that by typing git add test.txt and then press enter. Apparently nothing happened, but if we now type git status, this is what we get. As you can see, now we get a message saying that we have a new file in a green colored font, and we also are informed that this file is ready to be committed. Let's visualize what happened. The file moved from the untracked status all the way to the staged status. Git does this because he considers this file ready to be committed since you added it after finishing all the work you were going to do on it. Now let's take our first snapshot. We do that with the git commit command. Git commit will take a snapshot of all the files that are on the stage status and group them in one package we call commit. So type the following: git commit -m our first commit. Here's what we see. Git is telling us that one file changed and that there was one insertion which corresponds to the one line we created on the test.txt file. And finally, and very important, that we have a snapshot identified with the string 1bf0f04. This is called the hash, and it's a unique identifier for this commit. From this point on, I can come back to the state of the project as it was by this moment of time by using that identifier. Now if we do a git status, we will see that we're on a clean slate and that there's nothing to commit. Now let's see this on our file status lifecycle diagram. As you can see, the file was incorporated into the snapshot 1bf0f04 with the current state of the file being stored in it. After the commit was generated, the file immediately moved to the tracked status and into a clean state. So now let's go ahead and make a change to the file. You should still have the Atom editor open, and if not, open the test.txt file again and insert a new line, test number 2, and then save it. As you can see, Atom marks the new line, line number 2, with a green bar, which signals this is a change on the file. It also displays +1 on the lower right indicator, telling us one more line was added to the file. Now let's do a git status to see what has happened. Here we can see Git has marked the file in red again, but this time it's in a different status, modified. In order for this file to be considered for the next snapshot, Git tells us we need to git add the file again. Since this file was on the tracked status, any changes we do to it are being picked up by Git. Why doesn't Git just add it to the stage status? Well, think about it. You might have saved the file, but that doesn't mean that you're done with the work. Not only that, it might be necessary to change other files before we're ready for the snapshot. So if you do changes and save them, it doesn't necessarily mean the files are ready to be committed. Let's see what just happened on the file status lifecycle. Here we see that the file now has a second line, test number 2, and that after we saved it, it was moved to the modified state. So let's say we have completed our changes and want to create a new snapshot with the current file modifications. We just need to issue the git add command again using git add test.txt. And let's do another git status. Here we see the file again in green color, and Git is telling us we can now commit this file as it is now on the stage status. Let's see this visually. As we can see here, the file is back on the stage status. We're satisfied with the changes, so we'll go ahead and commit this change by issuing a commit command. Once again, Git has generated a new hash for us. This time it's B48FABB. We are again in a clean state, so this is our status now. First we committed the second file change. And then the file went back to the track status and our repository returned to a clean state. Okay, so now we'll do something a bit different. We will modify our test.txt file, but also add a second file to the repository. So open Atom again and add a third line to the test.txt file and save it. If we do a git status, we get the following. Now let's add a new file. Go to the Atom file, select New File from the menu, and add one line of content. Second file. When you save it, Atom will ask for the file name. Just enter foo.txt. Now do a git status and you should see the following. Git is saying that we have two different buckets. The first is the test.txt file that's not ready for committing, which means Git thinks we're still working on it, and the foo.txt file, which is in an untracked status at the moment. Here's what this looks like on the status lifecycle. So let's say our work is done and now we want to add the new file foo.txt to the repository and also move the test.txt file to be ready to be staged. We can do a git add with each file, or we can do the following command. Git add dot. Notice there's a dot at the end of the command. This will add all files untracked and tracked to the staging phase. Now if we do a git status, we will get the following. In visual terms, this is what we have now. Both files are ready to be committed, and we can do that by doing the following. Git commit -m third commit. Notice how we have a new commit hash, FC96349, and that Git is reporting that two files were changed and two total new lines were created. So on the file status lifecycle, we see how we created the new snapshot, and then the files are back on the track status. As we have seen from our interactions with Git, there's a concept of history built in as we move along in the development of the project. Each commit is like a photograph of an organism as it grows and grows. Frequently, you'll want to review that history to make sense of the current state of the project or potentially resolve an issue that might have been introduced in a previous commit. The main way of interacting with the history of the project is by using the git log command. So go ahead and type git log and you will see something like this. Here you see all the commits we've done in our project so far, but notice they're in reverse order. Our last commit is the first on the list and the first is the last. The first line on each entry is the full commit hash. Notice that it is longer than the ones displayed after the commit is done. This is because we can reference most commits with the first 7 digits, since this is already a good amount of uniqueness, but internally that hash is even longer to make sure it is almost impossible to have two of them that are the same. The second line displays the full name and email of the author of the commit. As you can imagine, this is the same information we entered when we set up our user in the git config command we did earlier. The third line displays the date and time of the commit, with the time zone delta. In my case, it's -5 because I live in the East Coast of the United States. Finally, we see the commit message we entered when we created the snapshot. One thing you'll notice is that if the output is larger than your current screen, you will get the contents of the log in a paginated program called less. You can tell if you are in less mode if you see a semicolon in the bottom of the screen. In this mode, you can navigate through the contents of the file by clicking on the up and down arrows in your keyboard to advance line by line. You can press the space key to advance one full page and the B key to back a full page. You can also search for a string inside this window by typing the / key and then entering a keyword and pressing enter. To quit, just hit the Q key. If you want to always get the full output to the screen, you can change this behavior by using this config command. Git config core pager cat. That will make the change just for the current repository. If you want to make this change for all your repos, just add the -- global flag after the config word. If you want to change it back to the way it was, replace cat with less on the config command above. If we want to see just the last X commits, you can pass a number after the git log command with a dash. For example, to see the last 2 commits, you can do the following: git log -2. Another useful flag is -- line, which displays all the commits in just one line by listing the short version of the hash and the commit message. This is what that looks like. You can also combine flags. So for example, if I want to get just the last 2 commits in one line, you can do the following: git log -- line -2. There are some useful time-centric filters that you can use, and there are 3 flags you can use for this: since, before, and after. For example, let's say we want to get all the commits that happened before March 15 of 2017. You can do git log -- before equals 2017-03-15. You can also see the ones after March 1st of that year. Git log -- after 2017-03-01. You can put a very precise time and date by using the following format. This actually will display the last commit on my repo, as I only have one commit after 3 p.m. of that date. Git log -- after equals 2017-03-07 15-0000 -0500. You can also use natural language for date ranges, like git log -- since equals 2 days ago, git log -- after 1 week ago, or git log -- before equals 1 month ago. You can also search by the person who committed the changes, like git log -- author equals Jorge. You don't need to put the full name. It will search all committers whose name starts with Jorge. There is a number of other options available that you can explore by typing git help log. If you want to see what the codebase looked like at the time of these snapshots, you can do so by using the git checkout command. For example, let's see what our codebase looked like at the time of the first commit. First, do a git log to get the hash of the commit you're interested in, and then copy the first 6 or 7 characters. In our case, it's 1BF0F0. Then enter the following command: git checkout 1BF0F0. Git alerts us that this is a detached head, which means we cannot do changes and commit to the repository from this state. But we can look around as much as we want. If, for any reason, you would want to save this as a stable state or start developing from this point, you'd need to create a branch from this commit. We'll take a look at branches later on. If you take a look at the test.txt file on Atom, you'll see that it has just the first line, test number 1, as it was when we first committed. You will also notice that the full txt file is gone. This simple exercise shows you the power of Git and how everything we do is being recorded step by step. To get back to the normal state, you can do git checkout master. Let's see other useful Git commands. The first one is git move. Let's give it a try. Git move foo txt bar txt. If you do an ls, you'll see that the file was moved or renamed. But if you do git status, you'll see that the file is in a stage status, which means it would be considered on the next commit. Let's commit the change. Git commit -m moved foo.txt to bar.txt. If you now do a git status, you'll see that the repository is back in a stable state. Another useful command is git remove. It allows us to remove a file. Let's try it. Git rm bar.txt. Now if you do an ls, you'll see the file has been removed from the file system. But once again, our repository has changes to be committed. Let's do a git status. We need to commit to make this change permanent. Git commit -m removed bar.txt. It's important to note that both git move and git remove can be used for both files and directories. There are certain files or types of files that you might not want to include on your repository ever. Files like temporary files or local setting files or cache files. Git allows you to avoid adding those files or tracking them by creating a special hidden file called git ignore. One common example is a swap file generated every time we are editing a file. Let's create one manually by using the touch command. Touch test.txt.swp. Touch is a Unix utility that creates an empty file quickly. Now if we do a git status, we'll see that the file is detected by Git. But we know for sure we'll never want to add any files that end on .swp. So we'll create a git ignore file with Atom to ignore these types of files. Inside the file we type star.swp. That means that any file ending on .swp will be ignored. Save the file and do another git status. Now we see that the file is no longer pending to be added, and now git ignore is the one file pending. Let's add to the repository and commit it. Now if we try creating another swap file, you'll see that it's ignored as well. One more command that you'll use in certain situations is git diff. With this command, we can see the changes that we've done from one snapshot to another, or from one branch to another. Let's first do a small change on test.txt, add the line test number 4, and save. Then do a git add and check git status. Now we can see the changes that have been staged so far by typing git diff -- staged. You can ignore some of the information here, but as you can see in green letters, Git is telling us that the line test number 4 was added. We can also see the changes from our last commit and say the commit where we removed bar.txt. Do a git log one line first to see the commit hashes. Then we can do the one we want by doing git diff 41.6d17d. In here again, we can see on green that we added the git ignore file with the text swp, and we also see that we added test number 4 on test.txt. But wait, why don't we see that bar.txt was removed? The thing is that git diff is giving us the changes between the two commits, not including the changes that happened right before that one. So when we committed 416d17d, the file had already been deleted. There are cases where it's useful to use a special character, the caret, to denote the parent of the commit we're checking. We will use the caret in a couple of examples in the next section, but just think of it as the previous commit of that commit you're referring to. So back to our example, we want to see the changes between our last commit and when we removed bar.txt, including the change injected in that commit. Then we would do git diff 41.6d17d and then add the caret. Now we can see the deleted file section on red font. To see the changes between the current commit and the previous one, we can use the following: git diff head caret. Finally, we can see changes between two commits by putting two dots between the hashes. For example, we can see the changes between the second commit and the third commit by doing git diff b48 fabb fc96349. Notice the order of the commits. You want to do the oldest first. There are things we want to undo after we have pressed the Enter button on our keyboard, and Git allows us to undo a lot of them. Let's see some of the ways we can undo things in Git. As you might remember, we have stage changes on our repository after we added the test number 4 line on test.txt. Let's commit the file. But now, let's say we don't like that commit message. We can do the following: git commit -- amend. This allows us to change the commit message by presenting us with a simple text editor called VI. To edit the name, we need to hit the I key to enter insert mode in this editor, change the commit message, and then hit the escape key, then enter :+W, and then the letter Q. Here, I changed the commit message to read added important line on test.txt. Now if I see the last commit message, I see the corrected commit message. If you don't want to deal with the VI editor, you can change the editor Git uses with the command git config core.editor and then the name of the editor. In my case, I want to use Atom as my editor. Remember to pass --global if you want to make this change across the board. The command to be used is git config core.editor --atom --wait . Let's try that again. Notice how Git opened the Atom editor. I can do the changes to the commit messages and hit save. The caveat is that the commit message is saved only when you close the editor. So if you have the editor already open, it opens a new editor window, make the changes, hit save, and then close that Atom window. Another use of amend is when you forget to add a file to a commit you just completed. So for example, let's edit test.txt and add a line to it, test number 5. Save it, do git add, and then git commit m new change to test.txt. But then you realize that you needed to add a new file, foo.txt, to this commit. No worries, just create the file, add some content, save it, and then git add dot, and now instead of a regular commit, you do git commit -- amend. As you can see in the commit message, there's the modified file test.txt, but now we're adding foo.txt, and it's all going on the same commit. We can change the commit message if we wanted to. You can also do further changes to an already committed file and incorporate those changes to the existing commit. Go ahead and add another line to test.txt, like test number 6. Save the file and do a git add. Now, instead of doing the regular commit, do a commit amend. And you'll see that the file appears as modified. Save the commit message and close the window, and your changes will be incorporated. So let's say you created a new file called bar.txt and you add it to the repository. The file is now on the stage status, ready to be included in the next commit. But what if we change our minds and want to continue working on this file and not include it in the next commit? Git is already kind of telling us what to do. You just need to issue the following command: git reset head bar.txt. Notice that the file went back to its original status, which was untracked. If you try doing this with a tracked file like test.txt and you reset that file, it takes that file back to the modified status. There are certain times when you have made such a mess looking for a solution that you just want to undo all the changes back to when you last committed or even to the previous commit. Even though you might think that this is an unlikely scenario, it happens more often than you think. So go ahead and make some changes to the text.txt file. Go nuts and change all the lines if you want. Now save the file and check what Git status says. As you can read, Git tells us that we can discard the changes in the working directory with a checkout command. So go ahead and type the following. It's extra fun if you do it while keeping the atom window in view. Git checkout --test.txt. Magic! The file is now exactly the way it was before we did the changes. Now we're going to do something similar, but this time change multiple files and put a bunch of random text in them, making sure to save them. Do a git status and make sure they're all changed. Now we can issue the following command. Git reset head --hard. This will take all the files in the working directory to the state they were on the last commit. After you press enter, check the files and you should see they're back to their original state. Now let's say we have already committed a bunch of bad code. So go ahead and change all the files again with gibberish, but this time around save the files, do a git add and commit them using the commit message bad commit. Let's see the git log -2 to see the new commit is there. But now we realize this whole commit is wrong. Bad code all around. What can we do? Thankfully, Git makes it easy to discard this commit and go back to the previous commit. Just use the following command. Git reset head --hard. Notice we have a caret next to the head. Remember what that was? Right, the caret would refer to the parent commit of the one we're referencing. After you press enter, you should be taken to the previous commit and the files should be in their original states. You can check it by using git log. And that's the end of this section. Hopefully you now have a good grasp of the power of using Git. Go ahead and practice what you've learned, and I'll see you back in the next section. A basic component of Git is its branching capabilities. It used to be very complicated to do branching in other version control systems, and Git really brought this capability to developers in a seamless way. But why do we need branches? The answer is simple. You need to keep different streams of work for separate use cases. A basic example is the typical architecture of an application. You normally have a development environment where developers are actively working on the new features, a staging environment where more stable code is being tested by other non-engineering teams in the company, like the quality assurance team, product managers, or the sales team, and finally a production environment where the code that has been tested can be pushed to the rest of the world. With Git, you can have a branch for each one of the environments, and you would start work on the development branch, and when your work is good, you could then port or move that work to the staging branch, and after the testing is done, move the code to production to be consumed by your users. This action of porting or moving code is called merging, and Git allows you to do this easily with the commands we're going to see in this section. Let's quickly review the commit process. Let's say you have a repository with 3 commits. Master is the default branch Git creates when you initialize a branch, so even though you don't know it, you have actually been working with a branch already. Master is usually the branch associated with the production environment in tech companies. Most teams talk about master as the main branch where stable code is stored. Now, if we create a branch, we would do the following. Git branch new feature. Don't do this just yet on your terminal. We'll do it step by step later. Now with this command, we have the following. As you can see, there's no new branch per se, both master and new feature point to the same commit. However, Git knows you're currently working on the master branch. Why? Both master and new feature are called pointers, and that's basically what branches are. However, there's another important pointer called the head, which points to the local branch you're currently on. In order for us to start working on the new feature branch, we need to switch to it, and we do this by using the checkout command. Git checkout new feature. Notice how the head pointer is on the new feature branch. This is our signal we have switched to that branch. Now let's say we work a bit on the code, change a couple of the files, and now commit. Let's say the new commit hash is bf98. Both the head and the new feature pointers moved ahead one step from master. Now let's say we have a bug and we need a quick change on master. We switch to master by doing git checkout master. Now let's say we completed the work on master and commit it. We'll get a new commit hash, AA32, and we would have the following. We can now see that we have a more visual concept of a branch. This is called a divergent history. Notice how easy we can switch back and forth between branches using the checkout command and continue working on each branch. Continuing with the example, let's say that we have completed the work on the new feature branch. We did a checkout on the branch, did one more commit, and now we need to incorporate those changes back to the master branch. This is what we have at this moment. We can now do what's called a merge. Git does this by looking at the new changes done in the new branch and adding those changes to the files in the master branch. To do that, we need to do git checkout master and then do git merge new feature. What happens at this moment is that Git looks at all the changed files and incorporates those changes to the master files and generates a new snapshot, CA11, that has all the changed files. Notice that this commit is special in the sense that it has more than one parent. This is called a merge commit. And yes, the head is now at the CA11 commit. You can now delete this branch by doing git branch -d new feature. Now let's try doing these operations in our terminal. Go to your home folder by doing cd tilde, create a new folder, and initialize the repository. Set up your name and email with git config, and now create a file called test.txt and put one line of code in it. Add the file to the repository by doing git add dot, and now commit it and name the commit first commit. Now repeat this operation 2 more times. Add a new line, do the git add dot and git commit, and name the commit second commit and third commit. If you do a git log, you should see the following. Now let's do our first branch. Just do git branch new feature and press enter. You can now see that the branch was created by issuing the following command, git branch. As you can see here, the master branch has an asterisk next to it. That means that the head is currently pointing to master. You can also see the new feature branch in the list. Let's change the head to the new feature branch. Git checkout new feature. Now the head is at new feature. Let's do a change on the test.txt file. At the bottom, type, this is a line in the new feature branch. Now save and commit. Now switch back to master and create a new file called test2.txt. Add some content to it, save it, add it, and commit it. We now have a divergent history with master and new feature in different paths. Switch back to new feature using git checkout new feature. Notice how test.txt disappears from the file system. Do another change on test.txt, git add, and commit it. Now try doing a git log one line. Notice how the history only shows up until we diverged, and the log has no record of the last commit we did in master. Let's pretend we finished the work in the new feature branch. We now need to merge the changes we did on the new feature branch into master. So let's do a git checkout master to switch to the master branch, and then do the following. Git merge new feature. Notice how we get the editor as if we were doing a commit, which we are. This new commit will be the combination of the work we did on new feature and the last commit on master. Enter a message for the commit and save. Remember, if you're using the VI editor, just type the I for interactive mode, type the message, then do escape, colon, and then W and Q. Notice how the changes we did in test.txt are now in the master branch. Now, if you do a git log one line, you'll notice that the commits we did on new feature now appear as part of the history of the master branch. Finally, we can delete the new feature branch since we're done working with it. Git branch -d new feature. Often, you'll find yourself with merge conflicts. When Git tries to merge the content of a file from two different branches, where it doesn't know exactly how to merge it, it will throw an error. Don't worry, this is easily fixed. Let's create another branch. Let's call it appropriately conflict. Here's a trick you can do when creating a new branch. Instead of creating the branch and then doing a checkout, you can do git checkout -b conflict. That will create the branch and will put the head on it. Now change line 3 in test.txt with some text, save it, git add it, and commit it. Now check out master and change line 3 as well on test.txt, save it, git add, and commit it. Now try to merge the conflict branch into master. You will get a conflict error. Open the test.txt file. As you can see here, Git is confused with line 3. Which one is the right one? Git doesn't know, so it displays the version on the head or master and the version on the conflict branch. Git has effectively paused the merge process until you resolve this, and then you can commit when you're done. If you need to see the files in conflict, just type git status. All you need to do is edit the file and keep the version you want, making sure the file looks like it should. If you have more than one file, go ahead and open them, resolve the conflict, and save them. Finally, do a git add to stage all the fixed files. If you do a git status, you'll see if all the conflicts have been solved. To complete the merge, just do a git commit and the merge will have been completed. There is another method to merge two branches called rebasing. The theory behind rebasing is that your commit history is cleaner and that it appears more linear to people looking at the history. It's a little bit like writing a book. Think of merging as putting out the book with the drafts and the different corrections to the chapters, versus rebasing, which looks more like a finished book with each chapter telling a story in a logical fashion. Remember our previous example with the diverging branch? Now instead of merging, we're going to rebase the master branch onto the new feature branch. So we do git checkout new feature, git rebase master. Notice how we're putting the head on new feature and doing the rebase operation from there. What happens now is that Git goes to the common ancestor of both branches and then applies all the changes in those commits to produce a new linear commit that we'll call gg88 quote. This commit has the last commit on the new feature branch, but also has the latest master commits as well. Then we can just do the merge with master which will be what's called a fast-forward merge, because there's no real merging since the new commit already has the existing changes on the master code base. Git checkout master, git merge new feature. Okay, enough theory. Let's see this in action. Since we want to put the codebase on the state we were when we had 3 commits on master, do a git log one line and check the hash you have for the commit title third commit. Then do the following reset using that hash. Git reset -- hard. We now have the master branch with 3 commits. Now let's create the new feature branch and do a couple of commits. Git checkout -b new feature. Edit the test.txt and add the line, this is line number 1 in new feature. Save the file, git add and commit. Then repeat the operation and put, this is line number 2 in new feature. Save the file, git add and commit. If you do a git log, you should see the following. Now do a git checkout master and add a new file, test2.txt. Put some content on it, save, git add and commit. If you do a git log, you should see the following. Now go back and do git checkout new feature. Notice how test2.txt is not in the file system. Now do git rebase master. Notice how test2.txt appeared now in the new feature branch. If you do a git log, you'll notice also how it appears as if the work in the branch is linear. Git went back and applied the another changing master commit after the third commit, even though we know that's not how it happened. We had done the first commit in new feature before that. Now we could go ahead and check out master and merge new feature, and we would have master with all the changes in the order we have here, and really no merges happening. But I want to surprise you with one more feature of Rebase called interactive rebasing. Let's say that you don't want to show the 2 commits for the new feature branch when we rebase into master because the 2 commits are related. You can actually edit the history by doing an interactive rebase. Interactive rebase allows you to run a script that essentially allows you to change the order of the commits, merge commits, or delete commits in any way you want. You can even insert new commits if you wanted to. You should still be in the new feature branch and you shouldn't have merged with master yet. Go ahead and do the following command. Git rebase -i master. You will see a list of the commits we did on new feature that are going to be rebased into master. As you can see, Git now shows us commands we can apply to each commit. You can pick to use a commit, reward to use the commit but change the commit message, edit to stop the script in the middle to allow you to do any operations and then commit, and squash to use a commit but merge into the one below. You just have to type any of those keywords in front of the commit hash, and once you save the file and exit, Git will run this file as a script step by step. If you choose edit, the script will stop. You can do all the changes to the files you want, commit, and then do git rebase continue to continue the script where you left things off. If you don't want to do anything, delete all the lines that aren't commented out. Those are the ones with the hash sign, and save the file. Also notice that the order of the commits here is reversed from what you see on git log. Here, the oldest commit is on the top. So let's combine the 2 commits into one and change the commit message. If you're using the VI editor, remember to type I to enter edit mode. Once again, if you're using VI, press escape and then type :WQ. Once you do, Git starts the rebase script and presents you an option to enter a commit message. Notice how Git tells us in what step of the Rebase script it's currently at. Change the first commit message and then comment the second message by putting a hash in front of the one you don't want. Then go ahead and save the file with escape::wq. You should now see Git completes the script, and if you do a git log, you should now only see one commit. We can now go ahead and merge into master. Git checkout master, git merge new feature. If you do a git log, you should see the following. You can now safely delete the new feature branch. One final note, you can apply this commit history editing to the current branch by using the head pointer. So for example, let's say I wanted to rename commit messages or squash commits in the master branch for the last 3 commits. You would do the following command. Git rebase -i head -3. The tilde sign denotes the previous 3 commits. Git offers us a way to create special pointers called tags. Tagging is useful to mark points in your commit history that are important. Most of the times, tags are used to denote versions of your application. So let's say at this point we have completed version 1.2 of our application. You would then issue this command, git tag version-1.2. From this point on, this commit will be also referenced as version 1.2. To see a list of tags you've created, do git tag. You can also go to the repository at this point by doing git checkout version-1.2. Notice that it's just to browse around since you're in a detached head state. Most of the times, you'll be working with a remote repository that you and your team are using as a pseudo-centralized repository, although we already know that Git is a distributed version control system that doesn't need a central server. That central server can be a custom Git server, or it could be a commercially available one like GitHub or Bitbucket. I will be using GitHub for this section as it is one of the most popular ones, and everything you learn here is applicable to any remote Git server you'll use. So head over to github.com and create an account with them. Typically, you'll need to provide a username, email, and password. GitHub is completely free for public repositories, but if you want to keep some of them private, you will need to pay them a monthly fee. The first thing we want to do is create an SSH key to be able to push and pull code from your repositories. Think of SSH as a key and log pair that allows GitHub to know that you are who you say you are. The first step is to create both the key and the log files in your local computer. Open your terminal and make sure you are in your home directory, and then type the following command: ssh keygen -t rsa -c, and then your email. You will be asked where to save the file. Leave the default option by pressing enter. Then it will ask you to create a passphrase. I recommend you create one as an additional layer of security. You will be asked to enter it again. Your keys are saved on your home directory on a hidden directory called .ssh. Notice that there are 2 files, idrasa and idrasa.pub. We will need to upload the pub file to GitHub. Now go back to GitHub and find the settings option in the profile menu. You can find that by clicking on your user profile picture on the top right. Next, find the SSH and GPG keys option and click on it on the left list, and finally click on the New SSH Key button. On the title field, enter a label like My RSA Key, and now copy and paste the contents of the idrasa.pub in the key field. You can get the contents of the file by doing cat.ssh/id_rsa and then click on Add SSH key. Let's create our first remote repository. Go back to your profile, click on Repositories, and then click on the green New button. You will get a dialog to create a new repository. Just type test remote repo on the repository name and click on Create Repository. Now we have some options. We can create a new repository manually, we can import an existing repository, but we'll do the easiest option, which is using git clone. Git clone creates an initial local Git copy of a remote repository in your computer. Make sure to click on the SSH button on the URL section and then copy and paste the text or click on the little gray icon at the end. Now go back to your terminal, make sure you are on your home users directory and type git clone and paste the URL you copied previously. Git will warn you that you have cloned an empty repository. If you look at the directory now, you'll see you have a test remote repo directory. Now change to the directory and let's start doing some operations with our new repository. Make sure you're in the test remote repo directory and do a git status. You'll see you are in the master branch and that nothing has been committed yet. To see the remote repositories associated with this repository, you can do git remote-v. You will see there's two entries. They're both titled origin, but one is for fetch operations and the other is for push operations. Fetch is the action of getting changes from the remote repository to your local repository. Push is the opposite, publishing your changes from your local computer to the remote repository. Sometimes you could be in a situation where you pull from one repository and push to another, but it's not common. The origin is a default label for a remote repository, but you could potentially work with multiple remote servers and you would add them or subtract them. This is not common either. Let's set up the repository with the user's settings as usual. Git config username, your name, and git config user.email and your email. Make sure you use the same email you used to create your GitHub account. Create a test.txt and put some content on it. Git add and commit. Now we want to push this code on the remote repository. We can do that by doing git push origin master. Notice what it says in the results. New branch. The way to think about this now is that you have a local master branch and you now have a local tracker for the remote origin master branch. If you do a git status, you will see the following. Notice it says that your branch master is up to date with origin master. This means that both branches are caught up. Now try doing a change to test.txt, save it, git add and commit. If you see the git log, you'll see your second commit. But if you do a git status, you'll notice it says that your branch is ahead of origin master by one commit. As you can see, you have advanced one step ahead of the origin master branch. If you check your GitHub repository page, you will see that you still show only one commit. So in order for us to catch up, we need to do a new git push. Git push origin master. You will see your code push to the GitHub repository and you are caught up with origin remote. For the last example, we're going to get acquainted with pulling changes from the remote repository. When you're working with a team of developers, oftentimes they will be pushing code to the remote repository and you will need to get those changes incorporated to your codebase as you work along your own timeline. The main way we get these changes is by using git pull and git fetch. So I'm going to simulate that another team member just did a commit on the remote repository that you don't have available locally yet, by using GitHub's editing function. GitHub allows you to do small changes in their website, and although I don't recommend using this in a professional environment, we can get away with it for this test. So open your GitHub repository page and click on Create New File. On the top, name the file test2.txt and enter some content in it. Then scroll to the bottom and enter a commit message. Make sure the commit directly to master branch is selected and press on the Commit New File button. Once you commit, you will go back to the repository's homepage and you will notice there's a new commit. Now go back to your terminal and do a git status. You'll notice there's no mention of what just happened in the remote repository. So in order for us to get these latest changes, we will use the git fetch command. So go ahead and type git fetch origin. As you can see, Git is referencing this new commit identified by D33577F, but we don't see this locally yet. If you type ls, you will see that the file test2.txt is not in your file system. If you do a git status, you'll see that Git is telling you that your local master branch is behind one commit from origin master, and that we can do a fast forward merge. So now to advance our master head, we just do a git merge. Git merge origin master. So now we're back to a stable state, just like this. The process of pulling the changes and then doing the merge can be accomplished in one step by using git pull. To try it out, go to the GitHub site and select test2.txt and then edit it. Add a second line and then commit it. If you check the commits on GitHub, you should see the new commit. Now instead of doing a git fetch and then merge, we'll do a git pull. Git pull origin. As you can see, the changes were fetched from the origin server and then merged in one step. We can also have local and remote branches. This can be pushed or pulled just like we did with the master branch. Let's create a local branch and see how we can push it to the remote repository. Enter the following: git checkout -b local branch. Now let's change the test.txt file and add a line that says, this line created in local branch. Now save, git add, and commit. Now how do we get this branch up to our remote repository? Just do the following: git push -u origin local branch. What's the U flag here? It's short for set upstream, which helps us to not have to pass the branch name on subsequent pushes or pulls. Now if you look in the remote repository, you'll see that the branch appears there. You can switch to that branch by clicking on the branch name or by going to the branches menu and selecting local branch. Check out test.txt and you will see the line we've just created. Now let's say we finish the work in this branch. Let's switch back to master locally and merge the changes from local branch and delete it. However, this doesn't delete the remote branch. In order to do that, you will need to do the following: git push origin -d local branch. Now what happens if someone remotely pushes a new branch to the repository? Let's simulate that by creating a branch on GitHub. Go to GitHub and in your repository homepage, click on the branch master button and enter the name remote branch, and then click on the blue area that reads create branch remote branch. GitHub will create the new branch and switch to it. Now do a small change on test.txt, adding the line, this line created in remote branch, then commit it on the lower part of the page. Now go to the terminal. We would normally do a git fetch origin master to get the remote changes, but this time we have a new branch. If we knew the name, we could do git fetch origin remote branch, but more often you will want to get all new branches, so you use the following command: git fetch -- all. That will get all the changes in any branches and pulls new branches as well. As you can see here, Git tells us there's a new branch. If you now do a checkout to the new branch, you will see that test.txt has the change we did. Go back to your master branch now. Let's say somebody deleted that branch in the remote repository. Doing git fetch origin --all won't delete that branch locally, so we need another command for that. So go to GitHub, click on branches, and press the little trash can icon in the end of the remote branch line. Now if you go to your terminal, do the following command: git fetch --all --prune. As you can see here, the remote branch has been deleted. This is the end of our Git journey. Now the only thing you need to do is play with Git and learn some of the remaining tricks it has under its hood. Believe me, I still learn a new feature every other week. You now have a very powerful tool in your developer tool belt. Congratulations on making it all the way to the end. If you want to continue your development career, make sure to check out my other courses and sign up for my newsletter at www.fromzero.io.